Good day, fellows. Welcome to the channel. Today we are going to continue with the concept of transversal waves. But today I'm going to introduce new concept, transversal waves, which are firstly the frequency. What does the term frequency implies to you? It's so simple. The term frequency implies the number of cycle per unit of time. See, so simple. We also have what? Period. Period implies the time taken to complete a cycle. You see? Then we also have the term wavelength. The term wavelength implies the distance between two successive points which are in phase, which are in phase. Okay, see, then now from here let me highlight another thing, that the frequency can be calculated using this formula 1 over t, whereby f is the frequency, t is a period. It is measured in hertz frequency, then period in seconds. You see, so simple. Now what I'm going to do is, let me try to give you a diagram. I'll erase everything. See, erase everything. Then from here, let me give you this example. Let's say now we have a diagram which looks like this. See, which looks like this. Say this is our diagram. We have A, B, C, D, say E, F, G, and H. Let's say this point is 5, and let's say this one is -1. Then from this point up until H, they give us 7. Let's say this one is 7 meters. And also, if they say to us now the distance from B to F, sorry, the time take for this wave to move from B to F, it is 0.5 seconds. Let's say this is all our given information. Then they ask us firstly to find what? The amplitude. How are you going to determine the amplitude? We always use this formula, max minus minimum divided by, 1 over 2, you open bracket, maximum minus minimum, which is going to be, maximum is 5 minus 1, which is going to be 1 over 2. 6, half of 6 is 3. Done. You see, this one, it wasn't that difficult. But now, let us continue. Number 2. Let us continue with number 2. How are you going to find the wavelength now from that diagram? Check. It's not difficult. Today I want to teach you this skill to say, if let's say we have a diagram, then we take the very same one like this. We have a diagram like this. You see? Then I've also made points. You see? Then from this point up until that point, from this point up until maximum, I'm going to have 1 over 4. Same as this one, 1 over 4. I break down my wave into quarters. You see? Then you can then ask yourself to say, if I add all this 1 over 4, what I'm going to get at the end of the day? Check. From this point till this point is so simple. 4 quarters, I'm going to get 1 lambda. See? I'm going to get 1 lambda. Then now, let us consider the remaining portion. From this one, I add this one, I'm going to get half. Then I take a half, I add a quarter. I'm going to get 0.75 watt lambda. You see now. Then at this point, you can then add what? These two values, which is 1 lambda plus 0.75 lambda. Then equate it to the entire distance, which is 7 meters. When I add these two, I'm going to get 1.75 lambda equal to 7. Let us take our calculator and solve for lambda, our wavelength. Going to get 7 divided by 1.75. Going to get 4 watt meters. You see? Don't forget this strategy when you come across your transversal wave. Then now, check. They also gave us that from B till F, it's 0.5 second. Now, the third question that will follow now is for us to determine what? The period. Don't forget that just now I stated to you that the period is the time taken to complete a cycle. You see? From B to F, B is somewhere here, then F is somewhere here. How many quarters do I have? 1 over 4, 1 over 4, 1 over 4, 1 over 4. I have 4. If I add these 4 quarters, I'm going to get 1. You see, it's a full cycle. For the fact that I'm going to add 1, if I take this cycle, which is like this, you see, which is like this, I have 1 over 4, 1 over 4, 1 over 4, together with 1 over 4. If I add all those 1 over 4, I'm going to get 1, which is a full cycle. Then now, the definition stated clearly that is the time taken to complete one cycle. Then that 0.5 is going to be our period in seconds. Then okay, we are almost there. Let us now determine what? The frequency. Let's say question number 4, the frequency. I still have some space. Frequency is given by 1 over t, which is going to be 1 divided by 0.5. Take your calculator. 1 divided by 0.5, we get 2. 2 is your final answer. Then hertz. That one. Then let's see if we can be able to determine the speed of this wave. Do you still remember the formula on how to calculate the speed of a wave? Let me assist you. It's like this: 4, 5, 5. Speed is given by frequency multiplied by wavelength. Do we have frequency? Yes. It's 2. Our wavelength in this case is, we got 4. See? Then if we multiply 2 by 4, we are going to get 8 what? Meter. You can just write meter per second like this. You see? Then this is going to be our speed. You see? Then yeah, we are done with this question. We have answered almost everything. Let's say now if I ask you to determine some crest on this diagram, is going to be B and what? And F. Then 7, find out or identify some trough. It's going to be D and H. You see? Then we are done with everything. The only thing that you can do for me is to practice these formulas to know them. You see, this one is of frequency, then this one is for speed. You see? Then we are done with almost everything. I thank you and enjoy.